Around 6 billion years ago, our solar system began as a quiet swirl within a vast cosmic cloud of gas and dust. This immense cloud, known as the solar nebula, floated gently through space, shimmering faintly with starlight from distant suns. Over time, gravity began its silent work. It drew together tiny specks of hydrogen and helium, guiding them into an invisible spiral. The cloud slowly collapsed inward, heating as it fell, until at the center a glowing core ignited. That radiant heart would become the young sun, the light that would one day warm the future worlds to come. Scientists have traced this story not through imagination, but through evidence locked within ancient meteorites. The Allende meteorite, found in Mexico in 1969, contains minerals older than Earth itself, whispering secrets of that early collapse. Within it are isotopic patterns, frozen in time, that tell us of the nebula's fiery birth and the dust that once drifted freely across the newborn galaxy. As the sun brightened, the surrounding cloud flattened into a graceful disk of light and matter. Inside that calm spiral, order began to rise from chaos, warmth from coldness, and movement from stillness. It is one of nature's quiet paradoxes that such beauty could arise from collapse. The solar system was not born in an instant, but through a patient dance lasting millions of years. What began as scattered dust now circled a brilliant center. It was the first step in a long unfolding story, a cosmic breath that marked the beginning of everything we now see and know. Like the first soft dawn after endless darkness, a world had begun to open its eyes. Before we begin, support Cosmic Sleep Science with a like, subscribe, or a gentle comment below, sharing the country you're watching this video from, as we embark on this cosmic adventure together. After the sun's light pierced the mist, the surrounding disk of dust and gas began to spin faster and thinner, turning into what scientists call the protoplanetary disk. Within this quiet halo, grains of rock and ice drifted gently, colliding and sticking together. These simple encounters, driven only by chance and motion, built larger and larger bodies called planetesimals. It was a slow and silent construction, like waves shaping sand into forms over countless tides. Yet not all regions grew equally. Near the sun, heat pushed away the lighter gases, leaving behind rocky fragments that would later become Mercury, Venus, Earth, and Mars. Farther out, where the cold was deep and shadows long, gas and ice gathered more freely, forming the immense worlds of Jupiter and Saturn. Scientists still ponder the speed of this creation. How could small grains turn into planets in just a few million years? Some believe a nearby supernova may have stirred the cloud, sending shockwaves that sped up the process. Others think that magnetic fields and turbulence inside the disk quietly guided the growth. Every world, large or small, carries the fingerprint of that ancient balance between heat and cold, light and shadow, chance and gravity. When we look at the planets tonight, we see not only their present beauty, but also the memory of countless tiny impacts that once shaped their birth. From the dust of stars came the foundation of everything solid beneath our feet. It is humbling to know that our beginnings were once no more than drifting grains in a glowing mist. Somewhere, perhaps, a distant star watched the same cloud unfold and wondered what might emerge. The solar system, calm and vast today, was once only a whisper in the cosmic sea. At the heart of the collapsing nebula, pressure and heat began to rise beyond imagination. Every particle of hydrogen was drawn closer, compressed under the weight of cosmic gravity. When the core reached around 10 million degrees Celsius, something extraordinary happened. The atoms fused. Hydrogen transformed into helium, releasing a surge of radiant energy. That first spark of nuclear fusion marked the true birth of our sun. It was no longer a cloud of gas, but a living star, burning quietly in the dark ocean of space. Its light spread outward, sweeping away the remaining dust and igniting the formation of the worlds around it. The idea of such a process was first suggested by Arthur Eddington in 1920, who realized that the energy of stars must come from the fusion of light elements deep within their cores. Modern science confirms this through the sun's spectrum, the unique fingerprint of its light. When scientists pass sunlight through a prism, they see delicate dark lines that reveal its composition, mostly hydrogen and helium, just like countless stars scattered across the Milky Way. This connection reminds us that our sun is not alone but one among billions, each born through the same timeless process. It is a fire without smoke, a light without sound, a rhythm without rest. From that small, glowing core came warmth, gravity, and the balance that would hold the solar system together. As the sun stabilized, the storm of its birth quieted. Space cooled around it, and the faint seeds of planets began to drift in its steady light. From a single spark within a vast cloud, a star had emerged to guide all that followed. From one bright point in the dark, an entire system found its beginning. The sun today holds nearly all the mass of the solar system, about 86% of everything that exists within its reach. This immense dominance is what shapes the graceful orbits of every planet, moon, and comet that circles it. Imagine a colossal mountain surrounded by grains of sand. That is the scale of the sun's power, silent yet absolute. Its gravity bends space itself, keeping Earth steady on its long path around the light. Scientists believe that during the solar system's formation, most of the nebula's matter fell inward, drawn by gravity into the sun's growing core. The remaining fraction, just a thin veil of dust, would later form all the planets and moons we know. This imbalance may seem extreme, yet it is the very reason the system remains stable. A smaller sun might have failed to hold its planets. A larger one might have burned too fiercely, leaving no room for life to grow. In this delicate balance lies a quiet perfection, a reminder that even in the vastness of space, harmony can emerge from chaos. NASA studies show that the sun's energy output drives not only the seasons and weather on Earth, but also the rhythms of the solar wind that shapes the edge of the heliosphere. Every breath of wind, every beam of light, is part of an unbroken flow from that central star. When we watch the sunrise, we are seeing the same fusion fire that began billions of years ago. If the sun had been smaller, perhaps too faint or too cold, the Earth might have been a frozen world adrift in darkness. The sun's strength is not only its size, but its perfect measure. It burns just enough to let life bloom beneath its steady glow. As the newborn sun continued to shine, its light and heat began to shape the destiny of the worlds that formed around it. Within the swirling protoplanetary disk, distance meant everything. Near the sun, the temperature rose so high that light gases could not remain. Only heavy elements such as iron, nickel, and silicate rock could survive the intense heat. From this fiery region emerged the four inner planets: Mercury, Venus, Earth, and Mars, small, dense, and solid beneath their thin atmospheres. Farther away, beyond the line where frost could form, the air cooled enough for gases like hydrogen and helium to condense. In that distant region, matter gathered in great abundance, building enormous worlds like Jupiter and Saturn, their forms wrapped in deep clouds and swirling storms. Beyond them, Uranus and Neptune took shape, born from ice and shadow, each carrying a trace of the sun's earliest breath. The difference between these two realms, one of rock and metal, one of gas and ice, is written into the structure of the solar system itself. Scientists have found proof of this ancient division through the study of meteorites such as Canyon Diablo. whose iron-rich composition mirrors that of Earth's inner core. Each sample of space rock is a silent witness to the early chemistry of the nebula, frozen from the time when dust first turned to stone. The pattern is clear, yet poetic. The closer to the sun, the harder the worlds became, while those far away remained soft and vast. Every planet, every moon, carries a memory of that balance between heat and cold, gravity and distance. Each planet is a story, written not in words but in fire and ice. Between Mars and Jupiter lies a wide and quiet region filled with drifting stones and metallic fragments. This is the asteroid belt, a place that divides the rocky worlds from the giants beyond. Though it circles the sun like the planets, it never became a planet itself. Scientists believe the reason lies in Jupiter's overwhelming gravity. The young giant's pull disturbed the material in that region, stirring it into constant motion. The fragments collided but could not unite. It is as if a great river once tried to form an island, but the current was too strong, leaving only floating pieces instead. Some asteroids are made of pure metal, others of carbon and ice, each a remnant of the early solar system preserved in silence. They tell us what might have been the raw ingredients of a world that almost came to be. The largest among them, Ceres, holds enough mass to form a sphere, yet it remains far too small to ignite the geological heart of a true planet. The rest drift endlessly, reflecting sunlight like distant sparks. The belt's beauty lies in its stillness, its slow rotation through the centuries, its fragments glimmering like the dust of forgotten dreams. Modern telescopes show that Jupiter's influence not only shaped the belt, but also protected the inner worlds from many impacts by catching or deflecting wandering comets. Even destruction can create balance. Even chaos can preserve life. The asteroid belt is both a border and a memory, marking the invisible frontier between two kinds of worlds. It reminds us that not every beginning finds its end. Perhaps it is the trace of a planet that never was, a dream left unfinished in the calm sea of space. Mercury, the smallest planet in our solar system, hides a secret deep beneath its scarred surface. Within its rocky shell lies a core made almost entirely of iron, taking up about 70% of its total mass. This makes it far denser than any other rocky world, an unexpected trait for such a tiny planet. The discovery came from the Messenger spacecraft, which orbited Mercury and measured its strange and uneven magnetic field. The data revealed a weak but persistent magnetism, suggesting that part of its metallic heart is still molten. It is as if a glowing ember remains alive within a stone that has long cooled. Scientists were surprised to find such a vast iron core, one that leaves only a thin layer of crust and mantle above it. When seen in sunlight, Mercury shines like a polished gem, yet its brightness hides the truth of its heavy heart. Its surface is covered in craters, silent witnesses to endless impacts across billions of years. Each mark tells of a world that has endured both fire and emptiness. Mercury may seem fragile compared to Earth or Venus, yet within it lies the density of a world forged by extremes. It travels closest to the sun, where light burns fierce and shadows vanish, a world where metal and silence meet. The more we learn, the more it feels like Mercury guards something ancient and untold. Its thin shell and vast inner weight make it both delicate and unbreakable, a paradox drifting in endless light. Though small and often overlooked, Mercury carries a quiet strength that has lasted since the dawn of the solar system. Even the smallest planet can hold the heaviest heart, and in that stillness, there is power. One possible reason for Mercury's enormous iron core lies in a violent past. Long ago, it may have been struck by another body, a massive impact strong enough to strip away much of its outer layers. The collision would have scattered rock and dust into space, leaving behind a world made mostly of metal. Scientists like Willie Benz proposed this idea in 1987. suggesting that Mercury once had a larger crust before it was peeled away by cosmic force. It is a haunting image, a planet once fuller, now bare and exposed, carrying the memory of a wound that never fades. Some researchers wonder if Mercury might once have resembled Earth more closely, with thicker layers of rock and a lighter core. The evidence remains uncertain, but its current form speaks of loss and endurance. The surface bears no sign of an atmosphere to soften its scars, only the sharp edges of craters and cliffs that rise from the heat-cracked plains. When sunlight hits, the planet glows like a fragment of the sun itself, reflecting light that reveals both beauty and sorrow. The idea that a single collision could change a planet's destiny reminds us how fragile creation can be. Each world in our solar system carries traces of destruction and renewal, and Mercury's story may be the most ancient of all. Scientists continue to study its orbit and magnetic field, hoping to uncover what truly happened in that distant age. Mercury's silence hides more than we can yet know. What did this small planet lose long ago? And what does its wound tell us about the restless heart of the universe? Venus shines brightly in the night sky, a soft golden light that once made ancient people believe it was a symbol of love and beauty. Yet behind that glow lies a world far harsher than any dream. The spacecraft Mariner 2 revealed in 1962 that Venus is wrapped in a thick atmosphere made almost entirely of carbon dioxide. This dense blanket traps heat with such intensity that its surface temperature rises to about 460 degrees Celsius, hot enough to melt lead. The pressure there is 92 times greater than on Earth, crushing enough to flatten a submarine. The air itself is filled with clouds of sulfuric acid that reflect sunlight so perfectly that the planet appears gentle from afar. Beneath those clouds, the ground burns like the floor of a vast furnace, and even the wind moves slowly through the heavy air. No drop of water can exist. No breeze can cool the heat. Scientists compare Venus to an endless kiln, its energy trapped and recycled without escape. The planet may once have had oceans, but now it glows in silence, a mirror of what happens when warmth turns against itself. In its beauty there is violence. In its stillness there is fire. Venus reminds us that even the brightest worlds can hide the fiercest storms. Its light reaches our skies each night, calm and distant, yet within that calm burns the memory of a lost paradise. The more we learn about Venus, the more it speaks to the fragile balance that keeps Earth alive. In every reflection of its golden clouds, we see both wonder and warning. Venus teaches us that beauty can carry the weight of fury, and that perfection can live beside destruction. Among all the planets, Venus moves in a way unlike any other. While most worlds spin in the same direction as they travel around the sun, Venus turns the opposite way. Its slow rotation taking 243 Earth days to complete a single spin. The spacecraft Magellan, which mapped its surface in the early 1990s, revealed deep valleys and high plateaus beneath a haze that never clears. Scientists still wonder what force could have reversed its motion. Perhaps long ago another body struck Venus, strong enough to tip it over and send it turning backward. It is as if a great dancer suddenly changed direction mid-step, continuing the rhythm but with a different grace. The planet now spins so slowly that one day there lasts longer than its year, its thick air moving faster than its ground, swirling like a slow dance of heat and wind. The mystery remains, yet it gives Venus a strange beauty, a kind of loneliness among the planets. Some believe it was once more like Earth, with oceans and a cooler sky, before heat consumed it and gravity slowed its heart. The story of Venus is a story of change and memory, a tale written in motion and flame. To watch its light is to see both the past and the future of worlds like ours. Venus turns backward as if to look behind itself, as if remembering what it used to be. Perhaps long ago it was not so different from Earth before it changed its course and became a mirror of what we might become. Mars, The red planet carries the color of rust and dust, yet beneath that dry surface, it hides traces of an ancient blue world. Billions of years ago, rivers once carved through its plains, and lakes rested quietly in its craters. The Curiosity rover found rounded pebbles and layered rocks, silent evidence that water once flowed there for long ages. Each grain of sand tells a story of movement, of currents that shaped valleys and carried minerals from hill to hill. Scientists look at these patterns and see a reflection of Earth's own rivers and streams. Mars may have once had clouds that formed rain, and an atmosphere thick enough to keep warmth close to its surface. The planet's landscape still shows deltas where rivers met ancient seas, their outlines faint but enduring. To imagine Mars in that time is to see a world alive with the gentle rhythm of water. Now the rivers are gone, and the lakes are only marks on the ground. But their memory lingers in every crater and canyon. The planet's silence feels almost like a whisper of what once was, a reminder that even deserts remember rain. Curiosity's cameras captured sunsets that fade into pale blue before night falls, colors that tell us Mars was once both colder and warmer, older and younger than it seems. Beneath its quiet dust lies the story of life's possibilities, the promise that once, for a brief age, Mars may have felt alive. Mars speaks softly through its stones, telling of a time when it dreamed in the language of water. Today, Mars stands dry and cold, its sky thin and its air too weak to hold warmth. Scientists believe that the loss of its magnetic field allowed the solar wind to strip away its atmosphere. The MAVEN mission in 2015 measured how charged particles from the sun still flow against the planet, carrying bits of air into space each moment. Long ago, Mars may have had a shield strong enough to protect its surface, but as its molten core cooled, that shield faded. Without it, the wind of the sun began to take what was once its breath. The oceans vanished, and the rivers turned to dust. The ground cracked, leaving wide canyons that stretch across the equator, like scars of a slow and endless drying. The poles still hold ice, but even there, the frost cannot bring back what was lost. Scientists compare this change to a lake that slowly disappears beneath the sun, leaving behind salt and silence. Each discovery tells of a planet that once was vibrant but now endures in quiet endurance. Yet Mars is not lifeless in spirit. It holds memory in its rocks, and perhaps beneath its surface there is still moisture hidden away, waiting in the dark. The idea that it might have once supported life is not only science, but wonder. Mars reminds us that worlds can change beyond recognition. That loss can follow creation. It is a story both tragic and calm, like a dream fading with dawn. What if Mars once cradled life in its valleys and streams? What if the echo of that life still lingers somewhere beneath its frozen dust? The great red spot on Jupiter swirls in a crimson dance, a storm so vast it could swallow Earth twice over. For at least 300 years, since Galileo first turned his telescope skyward in 1610, this tempest has raged without pause. Picture a vortex of fiery clouds, spinning relentlessly, its winds roaring at speeds up to 432 kilometers per hour. On Earth, the fiercest ocean gales whip waves into chaos, but they fade within days. Jupiter's storm, however, endures, a churning masterpiece painted across the planet's face. The Voyager spacecraft, gliding past in the 1970s, captured its ferocity, revealing a spectacle of raw power. Imagine standing on a distant moon, gazing at this colossal whirlpool, its red hues glowing against Jupiter's creamy bands. The storm's size staggers the mind, a reminder of forces far beyond our world. It spins in silence, yet its presence hums with ancient energy, as if the universe itself breathes through it. The great red spot is a whisper of eternity, a mark of time that outlives empires and oceans. The great red spot holds secrets we still chase, Data from the Juno spacecraft in 2016 showed it shrinking, yet it remains larger than any storm Earth could muster. Why does it endure? Think of a flame that never dies, fed by an unseen source. Jupiter's thick atmosphere, dense with hydrogen and helium, might cradle the storm's energy. Sustaining its endless spin, scientists ponder this mystery, tracing patterns in the chaos. Each swirl hides a clue, a piece of a cosmic puzzle. What fuels this eternal vortex? Imagine a shimmering halo around Saturn, a delicate ribbon of ice, rock, and dust stretching 240,000 kilometers wide, yet as thin as 10 meters in places. Data from the Cassini spacecraft in 2004 revealed these rings as fragments of shattered moons, scattered into orbits like cosmic snowflakes. Picture them glinting in the sunlight, a miniature galaxy spinning in silence. Each particle, from tiny grains to mountain-sized chunks, dances in a delicate balance, reflecting light in a spectacle of fragile beauty. On Earth, snowflakes melt under a warm touch, but Saturn's rings endure. A frozen poem etched across the sky, the Cassini probe, weaving through the rings, showed their intricate layers, some braided, others rippled by the gravity of nearby moons. From a distance, they seem solid, but up close, they're a cloud of sparkling debris, weightless and eternal. Their beauty feels both distant and intimate, as if the universe crafted a jewel for us to marvel at. Saturn's rings are a poem written in ice and light, glowing softly in the cosmic night. As you rest tonight, let their radiance linger in your mind, a quiet wonder that invites calm reflection. Yet, these rings whisper of their own fleeting nature. Cassini's findings in 2017 suggest they may vanish in a few 100 million years. A mere moment in cosmic time. Think of sand slipping through your fingers, each grain carried away by unseen forces. The sun's gravity and Saturn's moons tug at the rings, pulling their material into the planet or scattering it into space. Why do they fade? Scientists chase this question, studying the slow erosion of this celestial marvel. Each particle lost is a note in a fading melody. Will the rings vanish before we unravel their full story? Picture a planet rolling through space, tilted at a staggering 98 degrees, as if a cosmic hand nudged it off balance. When Voyager 2 sailed past in 1986, it revealed Uranus spinning on its side, unlike any other planet in our solar system. Imagine a spinning top, knocked askew, wobbling in a strange, endless dance. Scientists believe a massive collision long ago tilted its axis, setting it on this peculiar path. Its pale blue-green hue, caused by methane clouds, glows faintly, like a distant ocean under starlight. This odd tilt creates seasons that last decades, with one pole basking in sunlight for 42 years, while the other lies in shadow. From afar, Uranus seems serene, yet its lopsided spin tells a story of ancient chaos. Voyager's images showed a world that defies expectation, rolling along its orbit as if playing by its own rules. Its moons, too, follow this tilted journey, orbiting in sync with their planet's strange rhythm. Uranus dances a dance unlike any other in the cosmos, a quiet rebellion against the ordinary. As night wraps around you, let this image settle, a planet twirling in its own unique waltz, inviting you to ponder its mystery. Uranus holds another enigma, its atmosphere the coldest in our solar system, plunging to a bone-chilling 224 degrees Celsius. Voyager 2, in 1986, uncovered this frozen secret, a world colder than even distant Neptune. Think of an ocean locked in eternal ice, its surface unyielding. Why so cold? Scientists suspect Uranus lacks internal heat, perhaps due to its unique structure, stifling the warmth that other gas giants radiate. Its faint clouds drift in silence, a frozen realm untouched by fire. Each gust of wind carries the bite of absolute cold. What makes Uranus this icy jewel? As you rest tonight, let the question linger, a frosty riddle glowing softly in the cosmic dark. Picture a cataclysmic clash 5 billion years ago, when a rogue planet named Theia slammed into the young Earth. This colossal impact, proposed by Hartmann and Davis in 1975, sent molten debris spiraling into orbit, forming a glowing disk around our planet. Over time, this chaos coalesced into the Moon, a quiet companion born from destruction. Rocks brought back by Apollo 11 astronauts revealed a startling truth. The Moon's crust shares minerals with Earth's, like fragments of a shared story. Imagine glowing embers cooling into a silvery sphere, its surface scarred yet serene, reflecting sunlight across Earth's nights. The collision's violence reshaped our world, giving us tides and stabilizing our axis. Without this cosmic accident, Earth might spin wildly, its seasons unpredictable. The Moon's birth was a moment of fiery creation, a spark that lit up our skies for billions of years. Its gentle glow feels familiar, as if it remembers the chaos that forged it. From this wreckage, the Moon became our steadfast partner, orbiting silently, a beacon in the dark. As you rest tonight, let its soft light linger in your thoughts, a reminder of beauty born from turmoil, inviting you to marvel at its quiet presence. The Moon conceals a deeper enigma. Its core is small and lacks the heavy iron that anchors Earth's heart. Apollo missions in 1969 revealed this peculiarity, showing a Moon that feels almost hollow, like a lightweight sphere compared to our dense planet. Why so little metal? Scientists propose the impact with Theia left heavier materials behind, fused into Earth's core, while lighter debris drifted upward to form the Moon. This ancient collision crafted a satellite unlike its parent, a delicate shell orbiting in quiet grace. Its surface, pocked with craters, whispers of that violent birth, each mark a memory etched in stone. The Moon's composition puzzles researchers, its scarcity of iron a clue to its origin. Unlike Earth, with its churning, molten core, the Moon seems still, a relic of a lost catastrophe. Its faint pull on our tides binds us, yet its makeup sets it apart, a companion both familiar and alien. What secrets does it hold from that fiery dawn? The Moon holds the oceans of Earth in a gentle dance of gravity, an invisible thread first understood through the mind of Isaac Newton in 1687. Every wave, every tide, rises and falls as if the Moon whispers its silent command across the dark sky. When the Moon stands high above the horizon, the water below seems to lift in response, pulled by a force that cannot be seen but always felt. The oceans breathe in and out through this rhythm, swelling toward the Moon and then retreating back again, like the slow inhale and exhale of a living planet. This is the heartbeat of Earth, the pulse that reminds us of our place within the grand order of the cosmos. Each tide traces the motion of the heavens, echoing the balance between motion and stillness, between pull and release. Beneath this vast movement, countless lives depend on its flow. From the smallest shells resting in shallow sands to the mighty whales crossing silent depths, the Moon and Earth remain forever linked, not by chains but by harmony, moving as one through time and space. Even when we stand far inland, away from the sound of waves, a part of that rhythm still moves through us, a reminder that we belong to something greater, something that breathes beyond the edge of our knowing. The Moon and Earth forever dance a timeless waltz. The Moon is slowly drifting away from Earth, retreating at a rate of about 8 centimeters each year, a truth revealed through the lunar laser ranging experiments begun in 1969. Scientists discovered that this slow separation is caused by the transfer of angular momentum. a delicate trade of motion between two cosmic partners. Yet beyond the numbers lies a quiet ache, as if the moon were a dear friend taking gentle steps backward, waving farewell across an ocean of time. Each passing year, the tides shift ever so slightly. The length of Earth's day changes by a fraction, and the balance between the two worlds adjusts with invisible patience. One day, far into the future, the moon will drift far enough that the tides will weaken, the rhythm will soften, and the Earth will spin alone with a slower breath. The thought carries both wonder and melancholy, for even the grandest companionships in the universe must change. Still, the light of the moon will continue to shine, crossing the empty distance to reach us, like an old letter sent from a friend who no longer lives nearby. The pull may fade, but the memory of its touch will linger in the sea and in our hearts. When that time comes, when silence fills the space where tides once spoke, perhaps the Earth will look up to the night sky and remember the dance they once shared, and whisper softly, "How will Earth miss the moon when it finally drifts away?" The surface of the moon is covered with countless scars, deep craters left behind by ancient collisions that took place when the solar system was young. There is no air to protect it, no atmosphere to soften the blows, and so every impact remains forever written into its face. When the Apollo missions returned with pieces of lunar rock in 1969, they brought home fragments of that cosmic history. Each crater tells a story of a meteor that once blazed across the darkness and struck the silent ground, leaving behind a mark that will never fade. The moon became a living record of time, a vast archive carved in stone. In its stillness lies the memory of 1,000 fiery encounters, moments when the universe reached out and touched its surface. To look at the moon is to see the past itself, frozen in silver light, untouched by wind or rain. The silence there is absolute, a calm so deep it holds the echoes of eternity. Through a telescope, the craters shimmer under sunlight, their edges sharp and untouched, like the lines of a forgotten script written by the stars. Each hollow, each ridge, each shadow belongs to a story that has no sound but speaks through its form. Every crater is a story told by fallen stars. The dark plains that stretch across the moon are known as lunar seas, or Maria. Though they hold no water, they are vast basalt plains formed by ancient volcanic eruptions that once flooded the lowlands billions of years ago. When Apollo astronauts explored them in 1969, they found frozen lava instead of waves, a landscape both barren and hauntingly calm. Yet one mystery remains. Why are these seas found mostly on the near side of the moon, the side we always see from Earth? The far side, hidden from our eyes, is rougher, thicker, and almost entirely without these dark plains. Scientists believe the crust on the far side is heavier, so lava could not easily break through. Perhaps the moon itself is uneven in its depths, a quiet imbalance that has shaped how it looks to us forever. When we gaze at its face, we see smooth shadows that once burned with fire, a memory of movement now still. These plains resemble ancient dried lakes, resting in silence under the endless night. No wind passes over them. No waves return their call. It is as if the moon carries two souls, one open and familiar, the other distant and unseen. We have walked on only one face, touched only one story. The other remains turned away, holding its secrets in the dark. What does the moon keep hidden on the side that never looks at us? Far beyond the warmth of the sun, Europa orbits Jupiter like a silent jewel wrapped in ice. Beneath its glittering surface lies a hidden ocean, vast and deep, holding more than twice the amount of water found on Earth. When the Galileo spacecraft arrived in 1995, it sensed something extraordinary. The readings showed a strange magnetic signature, the kind that could only come from a salty, liquid sea beneath the frozen shell. In that discovery, a new dream began to form, a world covered in ice. but alive beneath it. The crust of Europa may be tens of kilometers thick, yet below that lies a dark, endless ocean warmed by the pull of Jupiter's gravity. In the blackness of those waters, scientists believe energy and chemistry may come together in the same way they once did on Earth's ancient seas. If so, then Europa could cradle the possibility of life, hidden beneath a shell of silence. It is a world that glows faintly with reflected sunlight, a distant pearl that guards its mysteries well. Each glimmer on its surface is a whisper from the deep, a promise that somewhere in the cold, something may stir. Europa whispers of secrets buried beneath the ice. Across Europa's frozen plains run long, dark lines, deep cracks that cross its surface like the veins of another world. These fractures are shaped by the immense gravitational pull of Jupiter, which tugs at Europa with a strength that stretches and bends its icy shell. The moon flexes like a living creature, and as it moves, the stress tears open the crusts, creating vast networks of ridges and scars. Sometimes, from those cracks, plumes of water may rise into space, brief fountains that betray the ocean below. Scientists have watched these signs carefully, wondering if the surface and the hidden sea still communicate, if nutrients and heat travel through those fractures like messages between two worlds. The frozen plains shimmer with color when the sunlight strikes them, revealing streaks of minerals brought up from beneath. They are the scars of motion, the proof that Europa is not still but alive in its own quiet rhythm. It is a world that changes slowly, breathing through ice instead of air. Every new discovery draws us closer to understanding the forces that shape it and the life it might hold. One day, perhaps, a probe will dive beneath the ice, into that silent sea, and find what waits in the dark. Is Europa waiting for us to discover life beneath its frozen skin? Among all the moons that wander through the solar system, Ganymede stands apart, vast and powerful, carrying its own magnetic field like a quiet signature of independence. Discovered in new detail by the Galileo spacecraft in 1996, this moon revealed something no other had: a magnetic field born from within itself, not borrowed from its planet. It means Ganymede is not just a cold satellite, but a world with a beating metallic heart. Beneath its icy surface lies a hidden strength, a core that stirs with energy, creating invisible lines that reach far into space. The magnetic field bends the solar wind, shaping a tiny magnetosphere, the only one ever known to belong to a moon. Around Ganymede, charged particles dance in spirals, tracing patterns that glow faintly in ultraviolet light, forming an aurora that flickers across its frozen face. It is as if the moon were a cosmic lighthouse, casting its silent beam through Jupiter's vast domain. The sight evokes a sense of quiet wonder, for within its frozen crust lies the power of a planet. While other moons reflect light, Ganymede radiates its own invisible force, a reminder that even in the shadow of a giant, individuality can shine. Ganymede shines like a world of its own. The secret behind Ganymede's magnetic field lies deep within its hidden heart, where heat and motion combine in darkness. Scientists believe that beneath layers of rock and ice, there is a core made of molten iron and nickel, much like the one inside Earth. It is strange to think that a moon so far from the sun could still carry the warmth needed to keep its core alive. The Galileo mission of 1996 helped uncover this mystery, suggesting that the immense gravitational pressure of Jupiter might play a role. As Jupiter pulls and twists its largest moon, energy builds up, keeping the metallic core in motion. That slow stirring of liquid metal creates electric currents, and those currents give birth to the magnetic field that defines Ganymede's uniqueness. It is a quiet engine that never stops turning, hidden from sight but shaping everything around it. This small world mirrors the Earth in miniature, a reflection of our own planet's inner fire, yet wrapped in ice and silence. Its surface may seem frozen and still, But within it lies a restless soul, glowing with unseen power. The thought invites both awe and curiosity, for Ganymede reminds us that even in the coldest places, warmth can survive in the heart. What makes Ganymede so different from every other world in the solar system? Io burns with unending fire beneath the cold light of Jupiter. When Voyager 1 flew past in 1979, it captured images that defied all expectations: geysers of molten rock, fountains of sulfur, and vast fields of glowing lava spreading across a golden plain. This small moon, only slightly larger than Earth's own, revealed a surface alive with power. Its plains are painted in shades of yellow, red, and orange, colors born from sulfur compounds that melt and reform under heat. Every eruption reshapes its landscape, erasing craters and drawing new mountains in the same breath. The entire world seems to breathe flame, turning the darkness of space into a moving, living furnace. Scientists compared it to a cosmic foundry, a place where the elements themselves are forged anew. While other moons sleep beneath ice and stone, Io pulses with constant renewal, its molten rivers flowing like veins of fire across the surface. The thin atmosphere glows faintly from volcanic gases, a shimmering veil above chaos. It is a world that never rests, a reminder that creation and destruction are bound together in the same dance. Io is the flame that never dies in the dark. The mystery of Io's heat begins with the invisible pull of gravity. Unlike Earth's volcanoes, which rise from the motion of tectonic plates, Io's fiery heart is kept alive by the crushing embrace of Jupiter. As the giant planet pulls on the moon, its immense gravity stretches and squeezes Io again and again. Like clay being kneaded by unseen hands, the nearby moons Europa and Ganymede add their own tug, locking Io into an endless rhythm that keeps its orbit slightly uneven. Each turn around Jupiter bends its interior, generating friction and heat deep within. That trapped energy melts rock into magma, which bursts forth through countless volcanoes scattered across the surface. It is a slow, violent dance between worlds, where motion itself becomes fire. Scientists call it tidal heating, a process that turns gravitational stress into volcanic power. Without it, Io would be cold and still, another frozen body adrift in the outer solar system. Instead, it blazes with life and motion, forever remade by the forces that bind it. The thought carries both beauty and sorrow, for such energy comes with constant turmoil. The moon burns because it cannot stop moving. Will Io ever rest? Or will its fires burn for eternity? Titan, Saturn's largest moon, holds a secret that feels like a whisper from the cosmos. Its atmosphere, thicker than Earth's, wraps the moon in a hazy, golden veil, rich with methane, as discovered by the Cassini-Huygens mission in 2004. Picture a world cloaked in mist, like an early morning on Earth when fog softens the horizon, hiding secrets in its folds. Huygens, descending through Titan's skies, found rivers and lakes of liquid methane shimmering on the surface, a landscape both alien and eerily familiar. This isn't just a moon, it's a time capsule, a glimpse of what Earth might have been in its infancy. Raw and untamed, the air, dense with nitrogen and methane, scatters light in a way that bathes everything in a soft, amber glow, like a sunrise that never fully breaks. Imagine standing there, your breath catching as you see a world that feels alive, yet so strange, with clouds drifting above liquid shores. Titan's mysteries unfold slowly, each discovery pulling you deeper into its story. It's a place where science meets wonder, where every detail hints at possibilities we've only dreamed of. Titan is a dream of a second Earth, a world waiting to share its secrets. Titan's surface, veiled in a golden haze, hides a secret that stirs the imagination. The Cassini mission in 2004 revealed lakes and rivers of liquid methane, glistening under a dim, distant sun. These aren't Earth's sparkling waters, but pools of a strange, cold liquid, flowing across a landscape carved by alien winds. Could life exist in these methane lakes? Scientists wonder, their minds drifting to Earth's hot springs, where tiny microbes thrive in scalding, hostile waters. On Titan, the chemistry is different, yet tantalizingly complex, with organic molecules dancing in the atmosphere, forming chains that hint at life's building blocks. Picture a world where life might not need water, where methane nurtures something unfamiliar, perhaps a shadow of what we call living. The lakes, serene and still, stretch across Titan's polar regions, their surfaces reflecting a sky thick with mystery. Each ripple, each molecule, could hold clues to a biology we've never imagined. The thought lingers, like a whisper in the dark, pulling you closer to the unknown. What if, beneath that calm surface, something stirs, something alive, yet utterly strange? Titan's chemistry teases us, offering glimpses of possibilities that challenge everything we know. It's a puzzle, a quiet call to explore, to dream of life beyond our blue world. Is Titan hiding an alien life? Strange and wondrous in its methane embrace. Enceladus, a small moon of Saturn, sparkles with a secret that captivates the mind. In 2005, the Cassini spacecraft caught sight of dazzling plumes of icy water erupting from its surface, shooting into the void of space like diamonds scattered across a velvet sky. These geysers, bursting from a hidden ocean beneath the moon's icy crust, carry traces of salt and organic compounds, hints of a world alive with possibility. Imagine standing on Enceladus, watching these shimmering jets soar upward, their crystals catching the faint light of a distant sun. They're like Earth's geysers, those steaming fountains in Yellowstone. But here they paint a cosmic canvas, whispering of mysteries below. The water, laced with life's building blocks, suggests a chemistry that could nurture something extraordinary. Each plume is a message, a fleeting glimpse of an ocean locked beneath ice, waiting to share its story. The slow dance of these eruptions feels almost alive, pulling you into a dream of discovery. Enceladus is no ordinary moon. It's a beacon of hope, a world where life might flicker in the dark. Enceladus whispers of an ocean waiting to be explored. Take a breath. Let the image of those sparkling plumes linger. The night sky still has more to reveal. Beneath Enceladus's icy shell lies a hidden ocean, perhaps 10 kilometers deep, kept liquid by a warmth we're only beginning to understand. Data from Cassini in 2015 points to tidal heating, a cosmic force born from Saturn's gravitational pull, like an unseen hearth glowing within the moon. Picture a furnace deep inside, warming the waters against the cold of space. This heat, stirred by the rhythmic tug of Saturn, keeps the ocean from freezing, a delicate balance that feels almost miraculous. Could this warm, liquid world cradle life? The thought drifts like a quiet secret, teasing the edges of our imagination. On Earth, deep-sea vents nurture strange creatures in darkness, and Enceladus's ocean might do the same. Its waters, rich with potential, swirl beneath a frozen crust, hiding answers we ache to find. The moon's gentle warmth, born from cosmic tides, invites us to wonder about life's beginnings. Each clue, each molecule, pulls us closer to the truth. Is Enceladus the place where life's first spark ignites? Hold that question close. Let it spark your curiosity. The stars are still shining, ready to share more. Rhea, a quiet moon of Saturn, holds a delicate secret that feels like a cosmic whisper. In 2008, the Cassini spacecraft glimpsed signs of a faint ring system encircling it, making Rhea the first moon ever known to wear such a crown. Picture a soft halo of dust, so fine it's almost invisible, wrapping Rhea like a fragile garland woven from starlight. These rings, unlike Saturn's bold bands, are subtle, a delicate veil of particles shimmering in the faint glow of space. Imagine them as a cosmic flower crown, adorning a moon that drifts silently in Saturn's shadow. The dust, caught by Cassini's instruments, sparkles faintly, each grain a tiny piece of a larger mystery. This isn't a loud spectacle. It's a quiet beauty, fragile and fleeting, as if the universe paused to craft something tender. Standing on Rhea, you'd see this ethereal ring glowing softly against the dark, a reminder of how even the smallest details can captivate. The discovery pulls you into a story of grace, a moment where science meets poetry. Rhea wears a silken scarf of the cosmos, delicate and breathtaking. The faint rings of Rhea, discovered by Cassini in 2008, carry a mystery as old as the cosmos itself. How did such a delicate structure form? Scientists believe an ancient collision, perhaps with a smaller moon or asteroid, scattered debris into orbit, creating this ghostly halo. Think of sea foam, fleeting and fragile, dissolving almost as soon as it appears. Rhea's rings feel like that, a whisper of something long gone. The particles, sparse and fine, drift in a dance shaped by gravity, a remnant of some violent moment in the distant past. Could these grains be fragments of a lost world, shattered eons ago? The idea feels like a memory, soft and distant, yet vivid enough to pull you closer. Each speck in Rhea's rings holds a piece of the story, a clue to a cosmic event we'll never see. The rings, so thin they barely hold together, speak of a time when chaos reshaped the heavens. This quiet moon, with its delicate veil, invites us to ponder its origins. Do Rhea's rings tell the tale of an ancient collision? Join us at Cosmic Sleep Science with a like, subscribe, or a quiet comment below about Rhea's delicate rings. Let's dream among the stars together, far beyond the planets. In the deep darkness of space, comets begin their ancient journeys. These icy travelers, born in the distant Kuiper Belt and the vast Oort Cloud, drift thousands of astronomical units from the sun. As theorized by Jan Oort in 1950, picture snowballs adrift in an endless night, glowing faintly as they wander through the void. The Oort Cloud, a spherical shell of ice and rock, cradles these comets, sending them on paths that can take millions of years to complete. Like snowflakes lost in a cosmic storm, they tumble silently, carrying secrets from the universe's earliest days. Some are nudged by gravity, spiraling inward toward the sun, their icy surfaces gleaming as they approach. Each comet is a relic, a frozen fragment from a time when the solar system was just a whisper of dust and gas. Their journeys are slow, deliberate, crossing vast distances that make our world feel small. As they near the sun, they awaken, trailing shimmering tails of gas and dust that light up the night sky. These tails, born from solar heat, stretch across space, a fleeting gift to those who gaze upward. Comets are cosmic wanderers, carrying memories of the universe's dawn. Take a moment to picture those icy travelers, drifting through the stars. Comets are more than fleeting lights. They are time capsules from the birth of our solar system. The Rosetta mission in 2014 revealed that comets like 67P hold pristine materials, unchanged since the cosmos was young. Think of them as unopened books, their pages written in the language of creation. Locked in their icy cores are molecules from 6 billion years ago, preserved by the frigid depths of space. Unlike Earth, where time and heat rework the surface, comets remain untouched, their materials frozen in a cosmic deep freeze. Scientists believe this cold isolation, far from the sun's warmth, keeps their ancient chemistry intact. Each grain of dust, each molecule of ice, tells a story of a universe taking shape. When Rosetta's lander touched 67P, it found organic compounds, the building blocks of life, hinting at secrets yet to be unraveled. These comets, drifting through the dark, are like libraries waiting to be read. Could they hold the key to how our world began? Their silence feels alive with answers, each orbit a chapter in the universe's first days. Are comets telling the story of the day the cosmos was born? As a comet nears the sun, a dazzling transformation begins. Its icy core, warmed by solar rays, starts to vaporize, releasing gas and dust in a process called sublimation. First described by Fred Whipple in 1950, picture a shimmering ribbon of silk unfurling across the cosmos, glowing softly against the black void. The Rosetta mission, observing Comet 67P in 2014, it captured the spectacle, revealing a tail stretching far into space. This isn't just debris. It's a cosmic torch, blazing with reflected sunlight as the comet's ice turns to vapor. The tail, a mix of dust and glowing gas, dances in the solar wind, creating a fleeting masterpiece visible from Earth. Each particle catches the light, forming a glowing arc that can span the night sky. The beauty is transient, lasting only as long as the comet lingers near the sun. Some tails curve gently, others flare brightly, but all are delicate, shaped by forces we can barely grasp. Standing beneath such a sight, you'd feel the universe's pulse, a reminder of its endless motion. The tail's glow, soft yet vivid, pulls you into a moment of awe, a fleeting glimpse of something ancient passing by. Comet tails are paintings drawn with light and wind, fleeting and unforgettable. Comet tails stretch across space, sometimes spanning millions of kilometers, yet they remain astonishingly thin. As Rosetta confirmed with Comet 67P in 2014, why do they grow so vast? Imagine smoke trailing in a breeze, light and fleeting, carried far from its source. Scientists propose the solar wind, a stream of charged particles from the sun, pushes the comet's dust and gas into these immense, delicate arcs. The tail's length comes from this cosmic breeze, scattering particles across vast distances. Despite their size, these tails are fragile, so sparse that stars shine through them undimmed. Each grain, each wisp of gas, is a fragment of the comet's journey. Stretched thin by the sun's relentless push, this fragility hides a deeper mystery, a balance between creation and dissolution. The tail forms only when the comet nears the sun, a brief flare of existence before it fades into the dark. Could these glowing trails be more than debris? They feel like echoes, traces of a path carved through the cosmos. Their delicate dance invites us to wonder about the forces shaping them. Are comet tails the footprints of a cosmic journey? Comets, those ancient wanderers of the cosmos, may have played a role in life's beginnings. In 2006, the Stardust mission discovered glycine, an amino acid, in the dust of Comet Wild 2, a finding that sparked wonder. Picture comets as cosmic sowers, scattering seeds of life across the universe. These icy travelers, born in the solar system's infancy, carry organic compounds, the building blocks of life, locked in their frozen cores, like seeds falling onto fertile soil. These molecules could have drifted to Earth long ago, carried by comets crashing through the atmosphere. The discovery of glycine, a key component of proteins, suggests comets delivered more than ice and dust. They might have brought the raw materials for life, sparking the chemistry that led to oceans teeming with creatures. Each comet, glowing faintly as it nears the sun, is a messenger from the distant past. Its cargo a hint of creation's recipe. The thought stirs a quiet awe, as if the stars themselves had a hand in our existence. Their journeys, spanning billions of years, connect us to the universe's earliest moments. Comets may be the couriers of life, carrying its spark across the void. The oceans of Earth, vast and deep, may owe their existence to comets. A possibility explored by the Rosetta mission in 2014. How much of our water came from these celestial travelers? Imagine rain falling from the stars, each drop a gift from a comet's ancient journey. Scientists hypothesize that comets, colliding with early Earth, delivered water through cataclysmic impacts. Rosetta's study of Comet 67P found water vapor, though its isotopic makeup differed slightly from Earth's seas. Still, countless comets may have rained down over eons, their ice melting into the planet's growing oceans. Picture a young Earth, barren and dry, slowly filling with water from these cosmic visitors. Each impact, a spark of change, helped shape a world where life could thrive. The idea feels like a whisper from the past, a story of creation carried on icy wings. Could the waves that crash on our shores today be echoes of those ancient collisions? The mystery lingers, tying our blue planet to the stars. Are our oceans a legacy of comets? Between the orbits of Mars and Jupiter lies a vast river of stone, the asteroid belt, home to millions of rocky fragments drifting in the quiet of space. The Dawn mission in 2011 explored Ceres, the belt's largest resident, a dwarf planet among countless smaller shards. Picture a cosmic stream, its currents made of jagged rocks tumbling through the dark, each piece glinting faintly under the sun's distant light. These asteroids, some as small as pebbles, others as large as mountains, are like broken fragments of an ancient painting, scattered across the void. Ceres, with its cratered surface and hints of ice, stands as a monument to a chaotic past. The belt's rocks, forged in the solar system's infancy, carry scars from collisions that shaped their jagged forms. Each one tells a story of a time when the cosmos was young, a swirling chaos of dust and gas. As they drift, they form a silent gallery, a collection of relics that never became a planet. The belt's quiet beauty lies in its disorder, a testament to the universe's untamed nature. Standing among these rocks, you'd feel the weight of eons, each fragment a whisper from the dawn of creation. The asteroid belt is a museum of unformed dream, a place where time holds its breath. Let this cosmic river linger in your thoughts. The night sky still has stories to share. The asteroid belt, a cosmic puzzle, holds fragments that never became a planet, a mystery pondered by Viktor Safronov in 1969. Why did these rocks fail to unite? Imagine a jigsaw puzzle left incomplete, its pieces scattered across a vast table. Scientists suggest Jupiter's immense gravity disrupted the process, its pull tearing apart any chance of cohesion. These asteroids, born from the same cloud that formed the planets, were destined to remain fragments, locked in an eternal orbit. Picture them as remnants of a dream that never took shape, their paths dictated by the giant planet nearby. Each rock, battered by collisions, carries the marks of a violent past, a story of chaos and interruption. The belt's existence raises questions about what might have been, a world that could have rivaled Earth or Mars. Instead, it remains a scattered graveyard of stone, preserved in the cold of space. The mystery deepens as we wonder about the forces that shaped it, the gravitational tides that kept these pieces apart. Could these fragments hold clues to the solar system's early days? Their silent orbits feel like a memory, a tale of what might have been. Is the asteroid belt a memory of a failed planet? Ceres, the largest object in the asteroid belt, hides a secret beneath its rocky surface. The Dawn mission in 2015 revealed that water ice makes up about a quarter of its mass, a frozen ocean locked within a dwarf planet. Picture a gleaming gem, cold and radiant, nestled among the belt's scattered stones. Dawn's instruments found bright patches of salt and ice on Ceres' surface, signs of a hidden reservoir shimmering in the dark. This isn't just a barren rock, it's a world with the potential for something more. A place where water, the cradle of life, lies preserved, like a pearl glowing softly in the void. Ceres stands apart, its icy heart hinting at possibilities we can only dream of. The surface, scarred by craters, tells a story of eons. Yet the presence of ice suggests a spark of vitality. Could this frozen water once have flowed, nurturing the seeds of life? The thought lingers, pulling us into a quiet wonder about what lies beneath. Ceres, orbiting silently between Mars and Jupiter, feels alive in its stillness, a testament to the universe's hidden depths. Its icy glow draws us closer, inviting us to explore a world both strange and familiar. Ceres is a sparkling jewel among the rocks, a beacon of cosmic mystery. The ice on Ceres, discovered by Dawn in 2015, raises a tantalizing question. Why is it active? Picture a small world breathing softly, its icy surface stirring with faint traces of activity. Scientists hypothesize that internal heat, perhaps from ancient collisions or radioactive decay, drives cryovolcanism, creating icy geysers that leave salt and frost behind. These faint eruptions, like whispers from a sleeping giant, suggest Ceres is more than a static rock. The bright spots, gleaming in craters, hint at a subsurface ocean kept liquid by some hidden warmth. Could this dwarf planet, dwarfed by its neighbors, harbor a quiet vitality? The ice, preserved in the cold of space, may have been sculpted by impacts or geologic forces, each mark a clue to Ceres' past. The mystery deepens as we ponder what keeps this ice dynamic, what stirs beneath the surface. Like a faint breath in the void, Ceres seems to pulse with secrets, its frozen features telling a story of cosmic resilience. Each discovery pulls us closer to understanding this distant world, a place where ice and rock intertwine. Is Ceres living a quiet life, hidden in the asteroid belt's embrace? From the asteroid belt, meteorites have journeyed to Earth, leaving marks that echo through time. The Chicxulub meteorite, identified by Luis Alvarez in 1980, struck 66 million years ago, reshaping life itself. Picture a star falling, its impact so fierce it ended the reign of dinosaurs. This massive rock, crashing into what is now Mexico, carved a crater over 150 kilometers wide, triggering a catastrophe that reshaped Earth's history. Like a stone shaking the foundations of a world, it shows the raw power of the cosmos. These meteorites, fragments of the asteroid belt, carry the weight of creation. Their fiery descent a reminder of our planet's place in the universe. Each impact leaves a scar, a story etched in stone, whispering of forces beyond our control. The Chicxulub event, a moment of chaos, cleared the way for new life, a cosmic reset that shaped the world we know. Standing at the edge of its ancient crater, you'd feel the enormity of time, the fragility of existence. These rocks, falling from the belt, connect us to a universe both beautiful and brutal. Meteorites are a reminder of our delicate place. A fleeting note in the cosmic song. Hold that thought gently. The stars are still shining with tales to tell. Meteorites, like the Murchison meteorite that fell in 1969, carry ancient materials, iron, nickel, and organic compounds from the solar system's dawn. What stories do they tell? Picture a letter from the past, its words written in cosmic dust. Scientists believe these rocks are remnants of planetary cores, fragments of worlds that never formed. The Murchison meteorite, rich with amino acids, hints at the chemistry of creation, preserved in the cold of space. Each fragment, forged billions of years ago, holds clues to the universe's early days, a time when gas and dust swirled into being, like a treasure chest from the cosmos. These meteorites offer glimpses of a primordial world, their metals and minerals, untouched by Earth's processes, are snapshots of a forming solar system, The mystery lies in their journey, surviving eons to land on our planet. Could they reveal how the building blocks of life arrived? Their silent presence feels like a message, a connection to the stars. Are meteorites pieces of an ancient universe? Scattered across our world, far beyond the planets, where the sun's light fades to a faint glimmer, lies the Oort Cloud, a vast, invisible shell encircling our solar system. Proposed by Jan Oort in 1950, this region holds billions of icy bodies, each a frozen relic from the universe's earliest days. Picture a cosmic ocean of darkness, dotted with shimmering spheres of ice, drifting in silence. These objects, scattered across an immense void, form a boundary so distant it feels like the edge of forever. The Oort Cloud, the birthplace of long-period comets, cradles these wanderers until a gentle nudge sends them spiraling toward the sun. Like snowflakes suspended in an endless night, they wait, untouched by the warmth of nearby stars. This unseen realm, stretching far beyond Pluto, marks the outer limit of the sun's influence, a frontier where our system meets the galaxy. Each icy body, glowing faintly in the cosmic dark, carries a story of creation, a whisper from the solar system's birth. The vastness of the Oort Cloud stirs a quiet awe, its scale dwarfing all we know. Standing at its edge, you'd feel the weight of infinity, a place where time and space blur into one. The Oort Cloud is the final frontier of our solar system, a silent guardian of cosmic secrets. The Oort Cloud, stretching up to 100,000 astronomical units, is a mystery we cannot see, yet its presence shapes our understanding of the cosmos. As Jan Oort suggested in 1950, how do we know it exists? Picture a shadow you can't touch, its form revealed only by the paths it casts. Scientists infer its existence from the orbits of long-period comets, which arc through the solar system from unimaginable distances. These comets, taking millennia to complete their journeys, point to a distant source, a vast reservoir of ice. The Oort Cloud's enormity, potentially reaching a quarter of the way to the nearest star, defies comprehension. Its icy bodies, scattered in a spherical haze, remain untouched by telescopes. Yet their influence is undeniable. What forces stir this distant cloud, sending comets on their long voyages? The mystery feels like a whisper from the edge of existence, a secret hidden in the dark. Could other stars' gravity tug at this fragile shell? Or do unseen objects lurk within? The Oort Cloud, silent and vast, holds answers we may never grasp. Its presence challenges us to look beyond, to wonder what lies in the unseen. Is the Oort Cloud hiding something beyond our sight? Join us at Cosmic Sleep Science with a like, subscribe, or a quiet comment below about the fleeting journeys of comets. Let's dream among the stars together. In the distant reaches of the Oort Cloud, long-period comets begin journeys that span millions of years, as seen with the radiant Hale-Bopp in 1997. Picture a rare visitor, a fleeting star crossing the sky once in a lifetime. Hale-Bopp, with its glowing tail, captivated the world, a celestial wanderer from the edge of our solar system. These comets, born in the Oort Cloud, follow vast orbits, taking eons to circle the sun. Like a shooting star that lingers just long enough to steal your breath, they appear briefly before vanishing into the cosmic dark. Their paths, stretching across unimaginable distances, carry them through the silent void, where time seems to pause. Hale-Bopp's brilliance, lighting up the night for months, felt like a gift, a moment of connection to the universe's vastness. Each comet, a frozen relic, holds secrets of the solar system's birth, its icy core untouched by the sun's warmth for millennia. Their rarity makes them precious, a reminder of how small we are beneath the stars. Standing under such a comet, you'd feel the weight of eternity, a fleeting glimpse of something ancient, Long-period comets are the sky's rare guests, gracing us with their fleeting glow. What stirs long-period comets from their distant home in the Oort Cloud? As Jan Oort theorized in 1950, picture a boat adrift, carried by unseen currents across a vast sea. Scientists believe gravitational nudges from nearby stars or galactic tides push these comets toward the sun. Their journeys, spanning millions of years, begin with a subtle shift, a cosmic whisper from beyond our system. Why do they travel so far? The Oort Cloud, a fragile shell of ice, lies at the mercy of distant forces. Its comets easily swayed by the pull of passing stars. Each comet's path, a delicate arc through the void, feels like a message from the galaxy. Could they carry traces of other stellar realms? Their icy cores holding clues from beyond. The mystery unfolds slowly. Each comet a traveler with stories we can't yet read. Their long orbits, shaped by forces we barely understand, pull us into a dance of cosmic chance. The thought lingers, a quiet question about what lies beyond our reach. Do these comets bring tidings from distant stars? The Oort Cloud, a vast sphere encircling our solar system, holds remnants of the primordial nebula that birthed our sun. As Jan Oort proposed in 1950, picture an ancient library, its shelves filled with frozen relics from the universe's dawn. Scientists infer its existence from the orbits of long-period comets, which trace back to this distant reservoir. These icy bodies, scattered across a cosmic void, are like pages from the solar system's first chapter, preserving materials untouched for billions of years. Each comet, launched from the Oort Cloud, carries traces of that early chaos, a time when dust and gas swirled into planets. This distant cloud, stretching far beyond Pluto, feels like a memory kept alive in the dark. Its contents, billions of icy fragments, whisper of a time before Earth existed, a story written in frost and stone. Standing at its edge, you'd sense the weight of creation, a connection to the universe's earliest moments. The Oort Cloud, silent and unseen, holds the raw ingredients of our world, a testament to the patience of cosmic time. The Oort Cloud is the solar system's first memory, a treasure of the past. How does the Oort Cloud, proposed by Jan Oort in 1950, remain stable at the edge of our solar system? Picture a fragile cage, holding billions of icy bodies in a delicate balance. Scientists believe gravitational forces from the Milky Way shape its structure, yet its stability is a mystery. Why doesn't it drift apart? The Oort Cloud exists in a precarious equilibrium. Tugged by the sun's pull and the galaxy's distant tides, hypotheses suggest this balance keeps its comets loosely bound, ready to be nudged inward by a passing star. Its vastness, spanning up to 100,000 astronomical units, makes it a cosmic sentinel, both guarding and challenging our understanding. Could it shield our system from external threats? Or does it hold secrets that test our knowledge? Each comet it sends feels like a question, a fragment of the unknown reaching toward us. The Oort Cloud's fragility, a whisper of ice in the void, invites us to ponder its role in the cosmic dance. Is the Oort Cloud protecting us or daring us to explore? In the distant reaches of the Oort Cloud, long-period comets begin journeys that span millions of years. As seen with the radiant Hale-Bopp in 1997, picture a rare visitor, a fleeting star crossing the sky once in a lifetime. Hale-Bopp, with its glowing tail, captivated the world. A celestial wanderer from the edge of our solar system. These comets, born in the Oort Cloud, follow vast orbits, taking eons to circle the sun, like a shooting star that lingers just long enough to steal your breath. They appear briefly before vanishing into the cosmic dark. Their paths, stretching across unimaginable distances, carry them through the silent void, where time seems to pause. Hale-Bopp's brilliance, lighting up the night for months, felt like a gift, a moment of connection to the universe's vastness. Each comet, a frozen relic, holds secrets of the solar system's birth, its icy core untouched by the sun's warmth for millennia. Their rarity makes them precious, a reminder of how small we are beneath the stars. Standing under such a comet, you'd feel the weight of eternity, a fleeting glimpse of something ancient. Long-period comets are the sky's rare guests, gracing us with their fleeting glow. What stirs long-period comets from their distant home in the Oort Cloud? As Jan Oort theorized in 1950, picture a boat adrift, carried by unseen currents across a vast sea. Scientists believe gravitational nudges from nearby stars or galactic tides push these comets toward the sun. Their journeys, spanning millions of years, begin with a subtle shift, a cosmic whisper from beyond our system. Why do they travel so far? The Oort Cloud, a fragile shell of ice, lies at the mercy of distant forces, its comets easily swayed by the pull of passing stars. Each comet's path, a delicate arc through the void, feels like a message from the galaxy. Could they carry traces of other stellar realms? Their icy cores holding clues from beyond. The mystery unfolds slowly, each comet a traveler with stories we can't yet read. Their long orbits, shaped by forces we barely understand, pull us into a dance of cosmic chance. The thought lingers, a quiet question about what lies beyond our reach. Do these comets bring tidings from distant stars? The Oort Cloud, a vast sphere encircling our solar system, holds remnants of the primordial nebula that birthed our sun. As Jan Oort proposed in 1950, picture an ancient library, its shelves filled with frozen relics from the universe's dawn. Scientists infer its existence from the orbits of long-period comets, which trace back to this distant reservoir. These icy bodies, scattered across a cosmic void, are like pages from the solar system's first chapter, preserving materials untouched for billions of years. Each comet, launched from the Oort Cloud, carries traces of that early chaos, a time when dust and gas swirled into planets. This distant cloud, stretching far beyond Pluto, feels like a memory kept alive in the dark. Its contents, billions of icy fragments, whisper of a time before Earth existed, a story written in frost and stone. Standing at its edge, you'd sense the weight of creation, a connection to the universe's earliest moments. The Oort Cloud, silent and unseen, holds the raw ingredients of our world, a testament to the patience of cosmic time. The Oort Cloud is the solar system's first memory, a treasure of the past. Let this ancient archive linger in your thoughts. The stars are still sharing their tales. How does the Oort Cloud, proposed by Jan Oort in 1950, remain stable at the edge of our solar system? Picture a fragile cage, holding billions of icy bodies in a delicate balance. Scientists believe gravitational forces from the Milky Way shape its structure, yet its stability is a mystery. Why doesn't it drift apart? The Oort Cloud exists in a precarious equilibrium, tugged by the sun's pull and the galaxy's distant tides. Hypotheses suggest this balance keeps its comets loosely bound, ready to be nudged inward by a passing star. Its vastness, spanning up to 100,000 astronomical units, makes it a cosmic sentinel, both guarding and challenging our understanding. Could it shield our system from external threats, or does it hold secrets that test our knowledge? Each comet it sends feels like a question, a fragment of the unknown reaching toward us. The Oort Cloud's fragility, a whisper of ice in the void, invites us to ponder its role in the cosmic dance. Is the Oort Cloud protecting us or daring us to explore? Comets, those wandering travelers of the cosmos, trace long elliptical orbits that can span millions of years. As noted with Halley's comet in 1705, picture a lone bird soaring across a vast sky. visiting only once in a lifetime. Edmund Halley, with keen insight, predicted the orbit of the comet named for him, calculating its return every 76 years, a slow rhythm in the solar system's grand dance. These orbits, stretched and slender, carry comets from the distant Oort Cloud to the sun's warm embrace. Like a bird gliding through endless horizons, they sweep through space, their icy surfaces sparkling as they near the sun, trailing radiant tails. These journeys, sometimes lasting eons, reflect the universe's patient cadence. Halley's Comet, glowing brightly in its rare visits, feels like a fleeting gift, a moment of wonder before it fades into the void. Each comet, a frozen relic of the solar system's birth, moves with a grace that belies its ancient origins. Standing beneath its glowing tail, you'd sense the vastness of time, a visitor from the cosmos passing by. Their paths, crossing immense distances, remind us of the universe's scale, a quiet spectacle that stirs the heart. Comets are fleeting guests in the eternal dance, their visits brief but unforgettable. What alters the paths of comets? Like Halley's noted in 1705, as they journey through the cosmos, picture a boat drifting on a vast sea, nudged off course by unseen waves. Scientists suggest massive planets, especially Jupiter, with its powerful gravity, can disrupt comet orbits, bending their paths into new trajectories. Why do these shifts happen? The mystery lies in this delicate chaos, where a gentle tug from Jupiter's mass can reshape a comet's million-year voyage. Like waves pushing a fragile vessel, these gravitational pulls create unpredictable journeys, each deflection, a subtle twist in the cosmic dance, sends comets wandering anew, their orbits stretched or shortened. This interplay, driven by Jupiter's immense presence, feels like a conversation between giants, with comets as fleeting messengers. Could these altered paths hold stories of cosmic encounters? Their wayward trail, etched across the stars, whisper of forces beyond our grasp, inviting us to ponder their origins. Are comets telling tales of their wanderings? In the vast orchestra of the cosmos, the sun stands as a conductor, its gravitational pull binding the solar system in a delicate harmony. As Isaac Newton revealed in 1687, picture a radiant center, its invisible threads weaving planets, comets, and asteroids into a unified dance. Newton's insight unveiled gravity as an unseen cord, tying each world to the sun's embrace, like a web of light stretching across the void. This force holds Mercury's swift sprint and Neptune's distant drift in perfect alignment. Every planet follows its path, drawn by the sun's steady pull, a balance that has endured for billions of years. This gravitational song, silent yet powerful, ensures no world strays too far. Each orbit a note in a grand symphony. Imagine standing on Earth, feeling the sun's distant tug, a reminder of our place in this cosmic tapestry. The sun's gravity, ever present, shapes the motion of every rock and gas giant, creating order from the chaos of space. Its influence, though invisible, feels alive, a quiet force that binds the solar system's many voices into one. Gravity is the song that connects all worlds, a melody echoing through the stars. The sun's gravitational pull, as Newton described in 1687, weakens with the square of distance, yet its influence remains profound across the solar system. Why does this fading force still hold such power? Picture a whisper carried across a vast plain, soft but resonant. Scientists explain that gravity's delicate balance, diminishing precisely with distance, crafts the stable orbits we see today. Mercury feels a fierce tug, while distant Pluto senses only a gentle nudge, yet both stay bound. This inverse square law, a mathematical elegance, ensures harmony, allowing planets to glide without colliding or drifting away. like a whisper that travels far. Gravity's reach shapes the cosmos with subtle strength. The mystery lies in its precision, a force so finely tuned it holds worlds in place for eons. Could this balance be the universe's secret to stability? Each planet's path, from Venus's graceful loop to Saturn's wide arc, reflects this cosmic law, a testament to gravity's enduring pull. The thought stirs wonder, as if the universe itself is breathing in rhythm. Does gravity keep us forever in this cosmic dance? As we drift through the serene wonders of our solar system, from the graceful dance of planets to the fleeting glow of comets, we're reminded of the quiet beauty that binds our cosmic neighborhood. Each orbit, each icy traveler, tells a story of creation, a melody played across billions of years. The sun's gentle pull, the moon's silent whispers, and the asteroid belt's ancient relics all weave a tapestry of harmony and mystery. Picture the solar system as a lullaby, its rhythm soothing yet vast, inviting us to pause and marvel at our place among the stars. The universe, with its delicate balance of forces, feels alive, as if it breathes in time with our own dreams. These facts, glowing softly in the night, offer not just knowledge but a sense of peace, a connection to something far greater. Let's linger in this cosmic calm, where every planet, every comet, sings a song of eternity. The night sky, vast and tranquil, holds countless more secrets waiting to unfold. Join us at Cosmic Sleep Science with a like, subscribe, or a quiet comment below sharing the country you're watching from, as we drift together through the soothing wonders of our solar system.